Programming languages can be broadly categorized based on their paradigms, level of abstraction, and use cases. Here's an overview of different types of programming languages, along with their pros and cons.
Procedural programming languages. Examples include C, Pascal, and Fortran. These languages are based on the concept of procedure calls, where programs are structured as a sequence of instructions or statements. They use functions, loops, and conditionals to achieve tasks. Pros. Simple to understand and use. Good for tasks that require a linear, step-by-step approach. Efficient in terms of performance, especially for system-level programming. Cons, less flexible for complex applications. Code can become difficult to manage as the program grows larger. Reusability and modularity may be limited.
Object-oriented programming, or OOP languages. Examples include Java, C++, Python, and Ruby. OOP languages are based on the concept of objects that represent data and methods. They emphasize encapsulation, inheritance, and polymorphism. Pros promotes code reusability and modularity through objects and classes. Easier to manage and scale large and complex applications. Facilitates the modeling of real-world entities. Cons can have a steep learning curve for beginners. May lead to overcomplication if not properly managed. Sometimes less efficient than procedural languages due to overhead.
Functional programming languages. Examples include Haskell, Lisp, Scala, and Erlang. These languages treat computation as the evaluation of mathematical functions and avoid changing state and mutable data. Pros promotes immutability and pure functions, leading to fewer bugs. Facilitates parallel and concurrent programming. Offers high-level abstractions which can lead to concise and expressive code. Cons can be difficult to learn and understand for those used to imperative languages. Performance can sometimes be an issue due to the immutability of data, may not be as widely supported or adopted as other paradigms.
Scripting languages like Python, JavaScript, Ruby, and Perl are typically used for automating tasks and are often interpreted rather than compiled. They are really easy to learn and use with a straightforward syntax. These languages are great for rapid development and prototyping. They're cross-platform and often come with extensive libraries and frameworks. However, they may be slower in execution compared to compiled languages. Also, scripting languages are not always suitable for large-scale applications and can lead to messy code if not properly managed.
Markup and query languages such as HTML, XML, and SQL are specialized languages used for defining data formats or querying databases. They are essential for web development and database management. These languages are highly specialized for their domains, making them powerful in specific contexts. They often have simple syntax tailored to their use case. However, they are limited in scope and only suitable for specific tasks. The learning curve can be steep for complex querying or markup structures, and they are not suitable for general-purpose programming.
Low-level programming languages like assembly and machine code provide little to no abstraction from a computer's instruction set architecture. They are used for writing programs that interact directly with hardware. These languages are highly efficient in terms of performance and resource usage, providing fine-grained control over hardware. They are essential for systems programming, such as developing operating systems or embedded systems. However, they are extremely difficult to learn and use. Writing and debugging code in low-level languages is time-consuming, and the code is often specific to a particular hardware architecture, making it not portable.
High-level programming languages. Examples include Python, Java, and C#. These languages provide a high level of abstraction from machine code, making them easier to read, write, and maintain. Pros, they are easy to learn and use with human-readable syntax. They're also portable across different platforms and come with rich ecosystems with extensive libraries and frameworks. Cons, generally, they are less efficient than low-level languages in terms of performance. They abstract away hardware details, which might be limiting for certain applications. Additionally, they may have overhead due to interpretation or just-in-time compilation. Domain-specific languages, or DSLs. Examples include SQL, MATLAB, HTML, and R. These are specialized languages tailored to specific domains or industries, such as data analysis, web development, or scientific computing. Pros, they are highly efficient and effective within their specific domain. They can significantly reduce development time for domain-specific tasks and often integrate well with other tools and languages used in the same domain. Cons, they are limited in scope and not useful outside their domain. They may require knowledge of another general-purpose language for broader tasks. The learning curve can be steep if you are unfamiliar with the domain. Declarative programming languages. Examples include SQL, HTML, CSS, and Prolog. Declarative languages focus on the what rather than the how of problem solving, expressing logic without explicitly defining the control flow. Pros, they simplify code by focusing on the desired outcome rather than the steps to achieve it. They reduce the likelihood of certain types of errors by abstracting control flow and often lead to more concise and readable code. Cons, they can be difficult to debug or optimize. There is less control over the execution flow, and they may not be as flexible as imperative languages. Each type of programming language has its own strengths and weaknesses, making them suitable for different types of tasks. The choice of language often depends on the specific requirements of the project, the developer's familiarity with the language, and the broader ecosystem of tools and libraries available for the language. Don't forget to like and subscribe to Tech Studio 24 for your free tech tutorials.